Hello, good morning again. This time we will discuss Module 7, example problems in lateral earth pressure. Okay. So situation 1, a retaining wall with 5.8 meter high support soil that has the following properties. So the unit weight of our soil is 17.3 kilonewton per cubic meter. An angle of internal friction to be 26 degrees, the cohesion value to be 14.5 kPa. So now determine the following. Number 1, the normal force acting at the back of the wall, assuming there is no tensile crack occurs in the soil. Number 2, if there is a tensile crack, what is the location of the tensile crack measured from the surface of the horizontal backfill? And number 3, the active force acting on the wall if tensile crack occurs in the soil. Okay. So again, we have a one layer of soil which is supported by a retaining wall which is 5.8 meter high. Okay, so number 1, there no normal force acting at the back of the wall assuming there is no tensile crack occurs in the soil. So anong ibig sabihin ng problem na yun?
Ano daw ang kapan?
There is no tensile cracks in the soil. Okay. So there is a development of tensile cracking, okay, occurs when there is a resultant tensile stress in the soil. So meaning the soil is assumed to have a passive. So the soil is assumed to have a passive pressure, okay? So magkakaroon lang ng tensile crack, okay, kapag merong tensile stress. Okay? So ito siya, di ba? So ibig sabihin nito, for one layer of soil, again, for one layer of soil, so itong soil natin due to the lateral pressure due to soil has a zero pressure at the top. Again, this one, may zero pressure siya sa top. Okay? Since they have the pressure and cohesion is okay, the pressure and cohesion is the same in kapag the same sila ng direction, there will be no tensile cracking or there will be no tensile force. Okay, however, kapag there are different in direction, katulad nito nasa drawing ko, this one, magkakaroon ng tensile cracking. Okay? So ibig sabihin, the assumption for number 1 is to have a passive pressure. Again, magkakaroon lang ng tensile cracking kapag merong tensile stress. Okay? Magkakaroon ng resultant tensile stress. So, given the one soil pressure diagram. So ito yung soil, yan, this one yung soil. Okay? And ito yung sa cohesion value. Okay? So let's say ito ay 0 and ito ay let's say 20 kPa. And this one is 10 kPa. So if the cohesion is the same direction, meaning they have the same direction, therefore the resultant stress is 10 kPa at the top, then magkakaroon ng ganito. 10 kPa at the top and you have this 30 kPa at the bottom. Okay, 20 plus 30. This one. You have this 10, you have this 20. Okay, so meaning there is no tensile stress. Okay, walang tensile stress. However, kapag the soil and the cohesion is different in direction, meaning ganito, we have this one. Okay, you have this negative 10. So you have this value negative 10. Okay. You have this negative 10 and you have this 10 which is 20 minus 10. Minus 10 din to, which is positive 10 kPa. Okay, so So magkakaroon ng tensile crack or tensile stress at the top. This one. Okay. So paano ba i-clear yung drawings nito? Okay. So that is the assumption kapag no tensile crack, there is passive pressure. Okay, so note again that this is single layer and this is horizontal backfill. Okay, therefore, the formula for the K sub P, if you recall the formula for K sub P is 1 plus, you have this sign positive at the top. So 1 plus sine phi over 1 minus sine phi. Okay, therefore your K sub P, substituting angle of internal friction to be 26 degrees, you have this 2.561. Okay, so let's draw the pressure diagram. Okay, so for the soil we have this one, and for the cohesion you have this one. So again, the soil and cohesion is the same in direction, therefore you will add, okay, this one positive. Okay, so substitute all the values. You have the pressure at the bottom of the soil is K sub P gamma prime times H, or yung effective stress, and the cohesion is 2C square root of K sub P. Okay, so let's solve for K sub P gamma prime and H. Since K sub P is 2.561 and gamma prime, or the submerged unit weight, the soil is not saturated, therefore the unit weight will be 17.3 and the total height is 5.8. So the pressure at this soil is 256.971 kilonewton per square meter. Okay, then for the cohesion, 2C square root of K sub B, you have this 2 times the cohesion value, which is 14.5, and the K sub P is 2.561. Therefore, you get 46.409 kPa. Okay, so to determine the force, okay, again, to determine the force, pressure is equals to the volume of the diagram, considering per linear meter of the width of the retaining wall. So parang ganito yan, di ba? Ang force, okay, ang force, anong unit ng force? The force is kilonewton, right? Then pressure is kilonewton per square meter. So you will add or you will multiply area, okay, area for this to determine the pressure. Okay, so at first kasi yan, that is kilonewton per cubic meter. Okay, kilonewton per cubic meter multiplied by the minumultiply natin siya ng height. Okay, and you have this linear meter. Okay, linear meter mo siya. Okay, so ang nangyari, kaya ganyan, you have this force, which is the pressure times the area of the diagram. Okay, so that is how you determine the force. Okay, so force is equals to pressure times the area of the diagram. So you always consider per linear meter of the width of the retaining wall. So ibig sabihin ng per linear meter, into your screen, you have 1 meter length of your retaining wall. Okay, so the force at due to soil, the lateral force due to soil is F sub 1, and the lateral force due to cohesion is F sub 2. So solving for F sub 1, you have this pressure. So basically just solve the area of the triangle. Okay. So the area of the triangle is base times height over 2. Okay. So you have this base, which is 256.971. Okay. And you have this height, which is 5.8 meters. Okay. So 5.8 times 256.971 divided by 2, you get 745.216 kilonewton. Then for the force F sub 2 due to cohesion, so that is base times height. Your base is 2c squared of k sub p. Then your height is 5.8 meters. You get your F sub 2 to be 269.172. Therefore, the total normal force acting at the back of the wall is the sum of F sub 1 and F sub 2. Therefore, you will design your retaining wall, okay, based on the lateral force 8,014.388 kilonewton. Okay, so this will be our answer, assuming there is no tensile crack or assuming the soil is to have a passive pressure. Okay. So next question, if there is a tensile crack, what is the location of the tensile crack measured from the surface of the horizontal backfill? Okay, so again, this is a single layer, therefore, this is also a horizontal backfill. So for now, since alam natin nga kapag may tensile crack, ang K natin will be K sub A or yung active. So for the formula of active, that is 1 minus sine phi over 1 plus sine phi, you have this 0.39. Okay. Then this is the pressure diagram. Okay, the pressure diagram due to soil. Okay. Then your pressure at the bottom will now be K sub A gamma prime times H. And you have this cohesion, which is now in different direction. Okay, you have this 2c square root of K sub A, okay, is equals to this one. So mag-a-add lang siya, di ba? Yung pressure sa top, which is 0, this one is 2c square root of K sub A, different direction, you have 0 minus 2c square root of K sub A. Okay, then the pressure at the bottom, you have this K sub A gamma prime H, different direction, minus 2c squared of K sub A. So that is why you have this diagram at the bottom. Okay, so ang tinatanong is yung tensile cracking measured from the surface of the horizontal backfill. So this is the length of the tensile crack. Okay, so this is tension force, this one. This will be a tension force in your retaining wall, meaning, okay, meaning you have these walls. Okay, okay, there is a tensile force at this location, which is this one. Okay, so that is a tensile cracking. Ibig sabihin, magkakaroon ng tensile cracking dun sa soil natin due to that active pressure. Okay, so hanapin natin yung distance na yan. So let us solve for the following: K sub A gamma prime H. So that is 39.133 kPa. 2c square root of K sub A, that is 18.11 kPa. Then solving for this diagram, 0 minus 2c squared of K sub A, that is negative 18.110. Okay, then solving for the pressure at the bottom, just subtract this 2, you have this 21.023. So how to solve for this length tensile cracking? Okay, so consolidating our values, you have this negative 18.11 at the top and 21.023 at the bottom. So to find that tensile location, tensile cracking location, we have this unknown variable C. Okay, so this total length is 5.8, therefore this other length is 5.8 minus Z. Okay, so solving this Z by similar triangle. Okay, so meaning the angle over here, which is, let's say, alpha, and the angle over here is the same, which is equals to alpha, meaning we can do a similar triangle proportion. So how to do that? Just length or the tangent of alpha is equals to the tangent of this alpha. Okay, so tangent is tangent ba yung ginawa ko? Sorry, cotangent ang ginawa ko para mas madaling i-shift solve, nasa taas yung unknown. However, still yield to the same values. So Z over 18.11, then this length 5.8 minus z over 21.023. Okay, then using your calculator, you can solve for z, which is 2.684 meters. Okay. Okay, so this will be the answer of number 2, and meaning this 2.684 meters from the ground surface will form a tensile cracking inner soil. Then last question, active pressure acting on the wall if there is no if there is tensile cracking force in the soil. So the same dun sa problem 2. So hanapin lang natin yung active pressure. Okay? So this will be the diagram of your based from number 2 question. Okay, 2.684. Therefore, this one is 2.936 meters. So this is the only active pressure acting on the wall, this one. So therefore, you just need to solve for this area multiplied by the pressure. Okay, so that is this one. This is the only active pressure acting on the wall. So therefore, your F is 21.023 multiplied by 2.936 divided by 2. So that is the area of a triangle. That is 30.862 kilonewton. So this will be your active pressure acting on the wall. Okay, so do you have any questions, class? Wala naman? Kaya pa? Okay? O sige. Next situation 2. The retaining wall is supporting 2 layers of soil. So with different properties. So determine the following assuming active pressure. Okay, number 1 is the total active force acting on the wall considering 1 meter width. Number 2 is the overturning moment, and number 3, total active force if surcharge of 20 kPa is applied on the top of the backfill. So this time, this problem is now have 2 layers of soil. So they have different properties. The drain angle of friction of our topsoil is 28 degrees, and you have this 26 degrees at the bottom. Also, you have this groundwater table at 2.4 meters from the ground surface. Okay. So solution 1, that the problem is asking the total active force acting on the wall considering 1 meter width. So let's solve muna yung coefficient of lateral pressure. Your K sub A sub 1, which is the coefficient of lateral pressure at the top soil. So using this angle 28 degrees, you have this 0.361. And for the bottom soil, you have this 0.39. Okay. So again, there are 2 drain angle of friction at h equals to 2.4 meters. Okay. So at this location, okay. So at this location, and at this point, okay. So infinitesimal change at the top. Okay? Meron ka na agad 28 degrees angle of friction. Nandun na siya agad. Kung infinitesimal change at the bottom, you have this phi that is 26 degrees. So para siyang ano eh, let's say for example, you have a line. Okay, let's say you have a line. Okay? Ito yung isang lugar sa isang lugar. Okay? And this is yung isang lugar, let's say barangay ulit. So pinaghahatian lang siya ng isang line. Okay? Kapag lumagpas yung isang hairline mo dito, nasa kabilang barangay ka na. Kapag lumagpas yung isang hairline mo dito, nasa kabilang barangay ka na. So meaning we can we need to solve for this point, at this point 2.4 meters. So mangyayari magkakaroon ng 2 drain angle of friction at this point, yung paghahatian nila. Okay? So right before 2.4 meters and right after the 2.4 meters. And take note that you will also use gamma prime for saturated. Okay, meaning the submerged buoyant the submerged unit weight of the soil. Okay? So due to soil. So due to soil muna tayo. So yung una, yung at this location, you have this zero pressure. Okay? Then at this point, so increasing yan, di ba? Increasing linearly. So we should consider it as one soil muna, one layer of soil. So katulad ng ginagawa natin, this one is equal to K sub A gamma H. So therefore, this is 15.075. So this time, kino-consider natin yung K sub A sub 1. Siya yung before 2.4 meters. So paano naman yung after 2.4 meters? Again, meron dalawang angle of friction na mararamdaman sa this point, this 2.4 meters na location. Okay? So to solve for the other right after the 2.4 meters, you need to solve for this one, which is equals to K sub A sub 2 multiplied by gamma. Your gamma is the soil at the top, which is 17.4. Your K sub A sub 2 is this one due to this 26 degrees. And the height is 2.4. Again, that is 16.286. Okay? So ngayon, nandito ka na. Right after ka na sa 2.4. So you can now do yung simple one layer pressure diagram considering this soil. Okay? So mag-i-increase ulit siya, di ba? Mag-i-increase ulit siya due to this hanggang dito sa 3.6 meters. So yung increase niya is this one. So nagsimula ka sa 16.286 at the top. Okay? Dadagdag ka ng K sub A sub 2 multiplied by gamma prime times H. So 16.286 plus K sub A sub 2, which is 0.39. Your gamma prime, okay, the submerged unit weight, that is since this is saturated, you will subtract the pore water pressure, which is 9.81, multiply by the height 3.6. Okay, so this one is 28.066. So we have this, meron na tayong mga coordinates. So una, pressure at the top 0, right before 2.4, 15.075, and right after 2.4 meters, you have the 16.286. Then increasing siya, starting from 16.286, the new pressure at the bottom will be 28.066. Okay, so kumpletuhin natin yung pressure diagram. Ito siya. Okay, so the direction is to the left. Okay, now due to the groundwater or due to the water. Okay, so ang starting ng water natin is nandito. So this is zero pressure increasing at gamma H, which is 3.6 times gamma of water is 9.81. Therefore, due to groundwater, you have this 35.316. So wala nang iba, wala namang cohesion. Okay, wala pa naman ditong load, surcharge load. So meaning ito lang yung lateral pressure na nag-i-influence tong sa ating sa ating retaining wall. Okay, so adding this to pressure diagram. Okay, so due to soil and due to groundwater. Okay, so mas madali di bang mag-compute ng area if we divide the areas by triangles and rectangles. So considering this area 1, this as area 2, area 3, area 4, and area 5. So again, the increment of this line is 1.211 kPa, and the increment of this line is 11.78 kPa. So just subtract. Okay, subtract nyo lang yung mga points. Okay, then the total active force acting on the wall considering 1 meter width is basically the pressure multiplied by the just simply the area of the diagram. Okay. Just take the area of the diagram. So the total force is the summation of F sub 1, F sub 2, F sub 3, F sub 4, and F sub 5. So solving for F sub 1, okay, this one that is 2.4 meters multiplied by 15.075 divided by 2. Just the area of this triangle. Okay, the area of the second area, which is a rectangle, So that is 15.075 multiplied by the height 3.6. So base times height. The area of f sub 3, area sub 3 is also a rectangle, which is 1.211 times 3.6. The area of 4 is 11.78 multiplied by 3.6 divided by 2. And the area of the area 5 is 3.6 times 35.316 divided by 2. Considering 1 meter width, okay, you can have this total force equals to 18.09 for F sub 1, 54.27 for F sub 2, 4.36 for F sub 3, 21.204 for F sub 4, and 63.569 for F sub 5. So the answer will be 161.493 kilonewtons. Okay? So, ayun lang. Mag-solve ka lang for the coordinates of these points. And again, kapag may 2 drain angle of friction ka at H equals yung termination ng 2 different type of soil, right before and right after you have these 2 values. Okay? So, next is the overturning moment. So, sinulat ko lang yung nasaan yung point of location nila. Yung F sub 1 is nandito, nasa center of gravity of this area 1. F sub 2 is nasa center of gravity of this area 2. F sub 3 is the same, F sub 4 is the same, F sub 5 is the same. So what is the length of that center of gravity of that area to the bottom? Okay, so we are going to find the overturning moment at the bottom of our retaining walls. Okay, so the length of the center of gravity from the bottom. So alam kung kaya nyo na mag-solve nito. Again, kapag triangle, you have this 1/3 H at the bottom and 2/3 H at the top. Okay, so moment at the bottom. So yung F sub 1 multiplied by 4.4, your F sub 2 multiplied by 1.8, F sub 3, 1.8, F sub 4 is 1.2, F sub 5 is 1.2. Okay, so solving for the overturning moment, you have this 286.858. So this will be the moment. It should be M. Okay, moment is this 286.858 kilonewton meter. Okay. So last problem for situation 2, the total active force if a surcharge of 20 kPa is applied on the top of the backfield. Okay. So in addition to the active force due to the soil and water, we have this surcharge load. Okay. So for the surcharge load, if you recall the pressure diagram for a single layer for a pressure due to the surcharge load, that is Q times K. Okay, the surcharge load Q times the coefficient of lateral pressure K. Okay, so at the first layer, you have your Q times the K at the top. Okay, again, the K sub A sub 1 and K sub A sub 2. So the same case kapag dun sa transition ng different layer, different properties of soil, different angle of friction, right before and right after you have these 2 different pressure. Okay, so you have this at point 2.4. Okay, you have this 7.22. Okay, and dito sa isa you have this 7.8. Okay, so therefore you have this pressure diagram Q sub K sub A sub 1, so 20 times 0.361, and this Q times K sub A sub 2, which is 20 times 0.39, you have this 7.8. And the pressure naman is mula sa taas hanggang pababa is the same, so you have this 1. So summation forces, summation of F sub I is basically, di ba we have 5 areas kanina. So dadagdag na lang natin to, hindi na natin isulat. So yung sagot sa problem 1, which is this one, 161.493. Ngayon dadagdagan lang natin ito. You have this 7.22 times 2.4 times 1 meter and 7.8 times 3.6 times 1 meter. You have this 206 0.901 kilonewton. Okay, so again, this is the answer from problem 1. Dinagdagan na lang natin. Okay, so situation 3. Okay, so next problem, situation 3, a vertical wall with a smooth face that is 7.2 meter high and retains a soil with an angle of friction that is 27 degrees. The unit weight of the soil is 20 kilonewton per cubic meter. Number 1, compute the active thrust per meter run of the wall if the retaining walls with a uniform surcharge angle of 9 degrees. Okay, this time, this is not horizontal backfill. So you have this inclined backfill. So again, the problem is active. Okay? So ang sabi sa problem, compute the active thrust per meter run of the wall. Ibig sabihin, the assumption is you have active pressure. Okay? So yan yung assumption. So for the solution, so the same lang din siya since that is a one layer of soil. Okay, one layer of soil lang siya. So the formula for the K sub A is given right here. So yung beta is the 9 degrees. So that is the angle. Okay? That is the angle of uniform surcharge angle. Meaning yan yung soil sa taas. Di ba? Surcharge din yung tawag din sa soil sa soil sa taas. So you have this 9 degrees loads, 9 degrees inclination of backfill at the top. Okay? So solving for K sub A, cosine beta multiplied by cosine beta minus square root of cosine squared beta minus cosine squared phi over cosine beta plus square root of cosine squared beta minus cosine squared phi. Okay, so basically your P sub A has also an angle of P sub A which is 9 degrees from horizontal. So this formula comes from the transformation of angle. So the transform mo siya yung 9 degrees to horizontal. So you have this derivation based on das. So if you want to recall the derivation of this one. Okay. So yung cosine phi, yung phi angle natin is 27 degrees. Yung cosine beta is 9 degrees. Okay. So solving for K sub A, you have this 0.392. Okay. Then again, your P sub A. Okay. How to solve for P sub A? Diba, this is one layer of soil. So meaning the assumption is this one. Okay. So this is K sub A gamma H. And this one is also H. Okay. So solving for P sub A or F sub A is equals to area of this triangle. That is 1/2 K sub A gamma H times H. Okay. So therefore your P sub A is equals to 1/2 K sub A gamma H squared. So minsan kapag nakakita kayo ng mga handbook, ganito yung binibigay na formula because that is the derivation of the area of the triangle. Okay? So huwag kayong malito kapag ganyan kayo nakitang formula. Okay. So for P sub A, that is 1/2 gamma H squared times K sub A. Your P sub A is equals to 1/2 20 kilonewton per cubic meter. Your H is 7.2 square. Your K sub A is 0.392. So kaya ayaw ko tong ipakita yung formula na to, this one. Baka kasi malito kayo kapag iba na yung type of soil. Meron ka ng different layers. Kaya this time, just stick to the pressure diagram and just solve for the area of the triangle, area of rectangle. Okay, just use the pressure diagram. Okay. So for P sub A, you have this 203.21 kilonewton per meter. Because if you're the problem is considering 1 meter width, okay, When considering 1 meter width, the total P sub A per linear meter is 203.21 kilonewtons. Okay? So now kasi they're not considering, sabi niya dito per linear meter daw yung answer. So stick to the per linear meter. Okay? So this will be our answer. Okay, so basically they are the same. Yan, this one, the same siya dun sa concept ng ating horizontal backfill. Kapag horizontal or inclined lang siya, magbabago lang yung coefficient of lateral pressure. Okay, and this time, you have this anchored sheet pile. Okay, so this is a type of retaining wall structures. Okay, so this is an anchored sheet pile. Okay, meaning you have this sheet pile, ito, then meron kang anchorage. Ibig sabihin ito ay soil nail, para siyang soil nail. So yung anchored sheet pile supports a soil at a height of 5 meters above the ground. And the soil is uniform and has an angle of internal friction to be 30 degrees. The wall is provided with a tension rod 1.5 meters below the surface of the backfill, which is this one. So ito yung 1.5 meters. So meron kang tension rod or soil nail, should be. Okay, meron kang soil nail to support the lateral, to support the anchored sheet pile. Okay. And you have this internal friction to be 30 degrees, uniform dito, uniform dito. And also soil, which is 17 kilonewton per cubic meter. Number one, the depth to which the wall be driven below the ground, which is this unknown variable D. Kung gaano daw kalalim yung ibabaon ng sheet pile. Number two, passive force if the soil weighs 17 kilonewton per cubic meter. And what is the tension of the rod? Okay. So for this example problem of anchored sheet piles, okay, ganito lang yung pag-solve dito. You have these assumptions. So para siyang analysis of them eh. Kung sino yung mas mataas, that will be your upstream, your downstream. Okay, sino yung mas mababa, siya yung upstream. Ibig sabihin, mas matutulak yung nasa taas, yung nasa baba since mas malakas yung pressure dito eh. Mas malakas yung tulak dito dahil puno yung tubig. Dito naman sa ilalim, mas mababa yung tubig. So, ibig sabihin, mas malakas yung tulak sa taas. So, that is also the same dito sa case ng soil. Since mas marami yung soil sa taas, mas malakas yung tulak niya compared to this portion. Diba? Kasi magtutulakan yan dito eh. You have this lateral pressure and you have this lateral pressure. So, meron kasing soil sa ilalim. So, magtutulakan sila. Okay? So, therefore, we can see that this will be our active side and this will be our passive side. Bakit active side ito? Recall the active side assumption. Ang assumption sa active side is yung wall is away from the soil. And for the passive side, yung wall is towards the soil. Okay, this will be your soil. Ito yung wall towards siya. Kung ito yung soil, this is the wall, okay, away siya. So this is the active side and this is the passive side. Okay, so considering mo ito, just consider this type. Okay, so pumasok ito, ng ganyan, and this one is nag-out naman dito sa soil na to. Nag-away. Okay, ito yung delta mo. This one now is your delta naman sa loob. Okay? Is that clear? Okay. So therefore, you have this active side and passive side. So meaning you have to solve for K sub A for active side and K sub P for the passive side. Okay? And this will be our pressure diagram. So pressure diagram mo on active side and the pressure diagram on your passive side. Then the pressure at the bottom will be denoted as P sub 1 and P sub 2. This is the pressure at the bottom. Okay. Then solving for K sub A for the active side, you have this 1 minus sine phi over 1 plus sine phi. You have this 1/3. Then solving for the K for passive side, which is 1 plus sine phi over 1 minus sine phi. You have this value 3. Then we have this active force, which is F sub 1 and F sub 2 acting on the centroids of this pressure diagram. Okay, solving for F sub 1, basically that is the area of the triangle. So your pressure 1 or P sub 1 is, this will be the total length. I think naglagay ako ng total length. Wala. So the total length is 5 plus D. This total length will be 5 plus D, this unknown depth. Okay, and this total length will be D. Okay, so therefore, solving for F sub 1, which is P sub 1 times H over 2, your P sub 1 is K, pressure yung pressure is K times gamma H. Okay, this is your gamma, this is your H, which is 5 plus D, and this is your K. Okay, so sulat ko siya dito. This one is K sub A gamma H. Okay, so gamma, K sub your H and your K sub A. Then for the height, which is H yun dito, that is 5 plus D over 2. So simplifying this one, using K sub A is 1/3, you have this 17 over 6 multiplied by 5 plus D squared. So this will be your F sub 1. Then solving for F sub 2. F sub 2 basically is the area of this pressure diagram, which is P sub 2 times D over 2. Okay. So solving for P sub 2 is also K sub P, passive side siya. So K sub P gamma times D. Okay. So that is your P sub 2. So your P sub 2 will be gamma times D times K sub P times the H times the height over 2, which is D over 2. So simplifying, you have this 17 times D times 3 times D over 2. Therefore, you have this F sub 2, which is 51 over 2 D squared. Okay? So you have this F sub 1 and you have this F sub 2. Okay. So to be equilibrium and no overturning, the sum of the moment at the rods, okay, at this point at the rod will be 0. So summing moment at the rods, okay, at this point at the rod, okay. So solve muna natin yung mga lengths. Solve natin yung mga lengths. Unknown. So ano yung mga unknown length? So or the distance of the F sub 1 and F sub 2 from the rod. Okay. So for the F sub 1, that is 2/3 H, right? So for the F sub 2, you have this 2/3 D. Yan yung location ng kanilang center of gravity. Okay? So therefore, the distance of F sub 1 to the tension rod is 2/3 H minus 1.5 meters. So your H is 5 plus D. So this will be the distance of F sub 1 to the tension rod. Then the distance of F sub 2 to the tension rod. So kung ito ay 2/3 D, okay, so that is the distance of this ground to the tension rod, which is 5 minus 1.5. So that is the distance of F sub 2 to the tension rod. Now equate it to 0 to solve for F sub 1 and F sub 2. Substitute natin yung F sub 1 and F sub 2. And solving for the value of D, okay, equate it to 0. So basically, just use your calculator to solve for this type of problem. So you have this quadratic equation. Okay. So 5 plus D is a substitute sa F sub 1. And you have this sa F2 sub 2, substitute nyo. And the only unknown will be the depth D. Okay. So solving one equation, one unknown, you can solve for the value of D. So solving for the value of D, you have this 1.83 meters. So para mas malapit kayo mag-solve, di ba ilalagay niyo yung f sub 1 and f sub 2. So kapag mag-shift solve kayo, magtatanong siya ano yung value of x. So maglagay kayo ng value of x, let's say 1 meters. So ibig sabihin, if you recall your numerical solution, 'di ba mag-i-start siya sa initial points. So kapag mas malapit yung initial point nyo dun sa final answer, mas mabilis siya mag-solve for the values or for the unknowns. Okay? So this will be your solution for the unknown depth D. Okay? So next problem, what is the passive force if the soil weighs 17 kN per cubic meter? Okay, using your answer for problem 1, which is D is equals to 1.83 meters, and the passive force is F sub 2. Okay, this is your passive force. Therefore, your F sub 2, which is 51 over 2D squared, substitute your D, that is equals to 85.397 kN. Okay, then number 3, what is the tension in the rod? So to solve for the tension in the rod, just basically sum forces along horizontal. Okay, so summing forces along horizontal is equals to 0. Okay, so that is F sub 2 plus T minus F sub 1 equals 0. So balik tayo dito. So F sub 2, which is to the right, F sub 1 to the left, tension rod is assumed to the right. Okay, that is a tension rod. So therefore, F sub 2 and tension is the same in direction. Okay, so F sub 2 plus T minus F sub 1 is equal to 0. Solving for F sub 2 and F sub 1, F sub 2, therefore your tension rod is the difference of F sub 1 minus F sub 2. Your F sub 1 is 17 over 6, 5 plus D squared. And your F sub 2 is the problem 2, which is 85.397. So therefore, your T is equals to, the tension in the rod is 46.775 kilonewtons. Okay, so that is this last problems in our module 7. Okay, so do you have any questions, class?
Wala naman po, sir.